This is a Geek Leader podcast, and I'm your host, John Rauda. This show is all about helping us grow as leaders, become better technologists, and improve our lives both at work and at home. I hope you enjoy the show and learn a lot. Hello, world, and welcome to a Geek Leader podcast. I'm your host, John Rauda. Today's sponsor is A2 Hosting. I've been using A2 Hosting solid-state hosting solutions for our website at geekleader.com for many, many years now, and absolutely love their support, their service, and all the features that you get. You get access to cPanel. You get all of the things that you can imagine for a great WordPress experience, including their A2 optimized WordPress, which does extra security checks, extra lockdown. You can lock down your editor file so you can't edit anything inside there. You get alerts whenever there are file changes that are done. You can also do automatic updates, backups, and more with A2 Hosting. So highly recommend it. Go to geekleader.com/A2 to get more information and to sign up for their solid state turbocharged speed hosting today. Again, that's at geekleader.com/A2. All right, Geek Leaders, today I am honored to have Eric Olson on the show. Eric is a data science professional. He's also a former, I think as he called it on his Twitter account, a washed-up Division I football player from Northwestern University, which we won't talk about the Northwestern season so far because it hasn't been very pretty. But he's also the co-founder of Consensus, which is a company that uses data and science to find decisions and help things out. We're going to talk a lot about decision-making and future of search and wherever else we may go. With all that being said, Eric, welcome to the show.
Thank you. That is you're starting off with a bang, bringing up the Northwestern season.
Yeah,
not pretty. I was there not this weekend, the weekend before, to the 42-3 Wisconsin game, and it was actually it was one of the teams I was on 10-year anniversary of a bowl team that won, and we got to go on the field directly after we missed a 20-yard field goal down 28-0 when the fans were booing. So it was not. It was pretty much the worst timing possible to go out onto a field and wave for the crowd. So,
yeah. Well, you have Maryland next weekend, and I know they have they're going to be starting a freshman quarterback because of injuries. So,
yeah, we probably still won't win. But anyway, podcast will only be up from here because we're starting from the lowest point possible for me.
So if you don't mind, if you don't mind, just tell the audience a little bit about how you got to where you are today, and what is it that you guys are doing over at Consensus?
Yeah, great. So I'll give you a little background on myself. So yeah, went to Northwestern, played football there. I got like a pretty standard like business degree undergrad called organizational change. And then it was actually in my 5th year that I started to dive into data science, and I got my master's in predictive analytics. So basically how to take data and use it to make predictive forward-looking decisions. And from there, I got a job at DraftKings, the sports entertainment, sports betting company. And I worked in the data science and analytics department. Most interesting thing I did there was I built our models to predict user skill. So basically taking user bet history and plugging that into a machine learning model and making a prediction on, is this customer a predicted winner or loser? If so, how much? So basically, yeah, taking these large sets of user bet history and using that to make predictions about the skill level of players. And that's really where I kind of fell in love with data science and taking large sets of data to hopefully to take large sets of data and use that to spit out usable and interesting and actionable outputs. And that's in some ways what we're doing at Consensus. So at Consensus, we are a search engine that uses natural language processing, which is a subset of artificial intelligence, to take in questions and find answers in scientific research papers. The basic genesis of this is, I was a jock in a family of academics and researchers, and it's made me always love and appreciate science, but never have the skill nor attention span to actually say, hey, I have a question. I wonder what the research actually says about my question. And I've always wanted to be able to do that. So basically, could we use some of these same skills of taking these giant data sets and spitting out usable outputs and do that over this, incredibly valuable set of data that is scientific research. And it not only is it an incredibly valuable set of data, unfortunately, it's a set of data that is really only consumed by the same people who create it. and we're trying to build the tools that make that change. There's science. It's great that the people who are scientists and researchers spend all their day plugging through research papers, but again, they're the same people who are creating that data. And there needs to be tools that exist to make it more accessible and usable and actionable for everyday people, and that's what we're trying to do.
Yeah, 100%. And I know when I look at some of these, I'll hear like people cite studies on a podcast or something that I'm listening to, and they talk about it, and then you go back and you look, and that research study that they cited, only a really good research study will have 1,000 people read it, and it's like, exactly. Why aren't people like looking into this? This is good data.
And that what you just said is really how I came up with the idea. Is I'd listen to a podcast, I'd listen to a podcast with a neuroscientist on it, and you talk about all these ways to optimize your morning routine to best, kickstart all these processes in your brain to make you more productive and happier during the day. And I was like, holy crap, this is so useful. I want this information in the tips of my fingers. And it was basically exactly what you're saying. Like understanding the value that I was getting from just having a person who knew what the research said, distill it down to me in simple terms it was my favorite type of content. So basically, why can't I do this whenever I want to do it about all of these questions where I don't have to wait for a particular person to hopefully talk about a question that I have on a podcast that I may or may not even come across.
Yeah, exactly. I can remember the exact podcast where it came up to me. I was listening to Tim Ferriss interview Dom D'Agostino about the benefits of ketosis and ketones in your brain, and all this stuff. And I'm like, he's talking all this like really science stuff. He's citing all these studies, and no one has read these studies. You have
to wait for the gatekeepers of the information to come out and tell you. Right. So we are. That is, explicitly what we're trying to solve is make it so anybody who's interested in this stuff can take your question, type it into an easy to use search engine, and instantly get back insights from scientific research.
So some of this, why can't I use Google for this? Like, why can't I just go to Google and because I know Google scans texts and books and stuff like that, but what's the problem with that?
Yeah, great question. So there's a bunch of problems. The Google, I guess I'll start at the highest level. Google is great for many things, but for topics like this, it's just not what it's designed for. It is at its core an advertising-based engine where its goal is to sell ad space. That's how it makes money. And when a search engine is set up that way, it is just not going to be designed to get you reliable scientific information about these topics. Their North Star metric is engagement. It's not about reliability or reputability. And that rears its head in a lot of different ways. If you type in what are the best supplements for anxiety into Google, it rears its head in a very obvious way, because what you're going to get back, because we've done this search and it's the first page on our pitch deck, is a bunch of advertisements for supplements. You'll get your Athletic Greens advertisement. Not that there's anything wrong with Athletic Greens, but that isn't what should be coming up when you're looking for reliable scientific information. And that's the most like heavy-handed way that it affects your search experience. But it affects every other part of it too, because also what they're prioritizing is what is most likely to be engaged with. So they're effectively prioritizing popularity, which means that you're going to get editorialized content that is set up in a way to be clicked on. And it will have nothing to do with if that core source material is actually good information.
So while we're talking, I just did a test. I typed in best supplements for keto, because I mentioned ketones before, so it was fresh in my mind. The first thing that shows up at the top is a bunch of ads for buying products. And then right below that are 4 ads for ketone supplements. They're all say ad beside it, and then it gets into the first one that's not an ad, and it's for a company that sells products. And then another company that sells products, and then another company sells products, and then there's health.us news, and then there's places.
Is like a maybe reputable blog. Now, Google sometimes will. They do index PubMed, which is a repository of medical scientific papers, and they sometimes will surface those articles. But usually when you type these questions into Google, the best you can get is like a maybe reputable blog from like healthline.com, which I don't know anything about them. That they could be great, they could not be, but like that is like, that is the best you could possibly get.
At least they have a good name.
Yeah, right. You have to dig through 8 advertisements to get there, and then you're only getting to a place that is, manually curated content that may or may not be citing sources. Who knows?
Correct. Yep.
So
That's
yeah,
exactly what I'm saying.
yeah, the underlying problem is that it's an advertising based system, and again, it is great for some things. Like if you want to ask, when is the next leap year? You should type that into Google. It is very good at giving you answers to these widely known like facts. But if you want to know a deeper question that has research about it, like you just type in there, what are supplements for ketosis? Do ketones help my day-to-day mood? We are going to be much better served at delivering you information from actual research papers than something like Google would be.
Yeah, I think that's fascinating how you talk about how ads are kind of driving this. And it's all like we see the same thing with like media companies too, and media being driven by whoever their sponsors are for different pieces of content, different ads. And there's nothing wrong with that. That's just the way that that environment has kind of developed over time. How is it that your business can do this without having that same kind of influences?
Yeah, great question. Yeah, and there isn't anything inherently wrong with it. I think that's an important point. And in this, like, people can get carried away and think that these places are these giant evil corporations, and it really is just more as simple as they're just following incentives of the advertising companies that they make their money from, the advertising dollars that they get. Right? They're just optimizing their products to be better served to show ads, and unfortunately, the result of that can be very negative for the end consumer, but it isn't some back channel conspiracy of a bunch of guys in rooms with suits being like, how are we going to misinform everybody? It's not what's happening. Anyway, back to your question. So right now we're completely free, but in the future that will change, and we will be doing a freemium subscription model. So we think that this is the future of search. When products that can use this new natural language processing technology can get good enough that they're offering a service that people will pay for, that's what we'll see real change happen in the search world. Right now Google is so easy to use and it's free that it's hard to wean people off of it. So in order to get ourselves a bunch of users, and as we're continuing to make the product better, we're going to be free as well. But then in the future, there will be parts of our product that will be paywalled. And it will be some combination of the premium features that we're yet to build, that we say, hey, if we have some scoring mechanisms for each of the results, or we do some, one level deeper analysis of the whole page of results, we may put a paywall behind that. There will be a, $5.99 a month subscription, $5.99 a month subscription. Or we might do that in combination with some usage-based pricing, where it's you get 5 free. Beyond that, you pay us $7.99 a month or something.
So you guys, I teach part-time at Winthrop University. Are you guys going to be looking to like partner in with these universities so that their students will have accounts?
Yeah, we're actually launching with our first 2 universities later this month, and that's going to be another way. We're going to have subscriptions for individuals, so anybody can come off the street and have a premium account. But another way we're going to make money is sell to businesses who need this for either their, universities and their students, or call it like a consulting firm, and for all of their healthcare consultants, they want everyone to have access to this. We're actually going to be launching with 2 universities later this month, where we're going to be an official resource of the school, offered through the library, and all that fun stuff.
Yeah, because I know I teach computer science. I don't make students do research papers or anything like that, but students will tell me that, oh yeah, we're only allowed to use, published scientific studies and things like that, and it's difficult to go and search through them and comb through them. We'll find a title of an article and we'll go read it. It's nothing what we're looking for, Yep. So having something that could actually read all that data, and I imagine, what is your data set? Where's that coming from, and how is that managed?
Yep. Good question. So we are lucky enough to have a partnership with an organization called Semantic Scholar. So it is it's part of the Allen Institute for Artificial Intelligence, which is Paul Allen, the Microsoft founder's research foundation. And they have a database of about 200 million scientific papers. So effectively, they're like a Google Scholar competitor, but they're this nonprofit. And they do partnerships with other organizations that they will license their data to. So basically, if you can, prove that you have a mission statement that is pushing forward their mission statement, they will give you a license for the data. There aren't that many private companies that have been able to do that to our knowledge, but we were lucky enough to start a relationship with those folks, show them that what we're doing is different from what they're doing and is has a similar mission statement and goal. And we actually have a license for those 200 million papers.
Cool. So when you get that data, are you like pulling the whole thing and storing it, or are you processing it and then keeping how are those algorithms actually working from the back end when it comes to, you talked about natural language processing and figuring out what questions people are asking? Because I know I'm going to speak in a little bit different dialect and ask questions a little bit differently than like super genius, people that are creating these things.
Yeah. So there's a few parts to that question. So I'll start with like how we store it, and then I can talk a little bit about how we take in questions and like retrieve information. So yeah, we will. Another benefit of working with Semantic Scholar is we actually they have a downloadable data set, so we're actually able to store it in-house ourselves to then clean it and have it set up in a way that it can be run through our pipelines, and we don't have to rely on a third-party API anytime somebody's doing a search. So it's actually coming internally from us. And then as far as how like a search kind of works and how we're able to take in questions, basically the way I would describe it is the search is like this giant funnel. And so it starts with, if you type in a question, it will basically just take what you've asked and say, what are the keywords of this query? And then try to get a subset of papers. So it's like the top 2,500 papers that have the best matches within the title and the abstract of the paper to those keywords. And the reason why we do that is because keyword is really fast and requires like basically no computing power. So basically just reduce, instead of searching through 200 million papers of doing this like hardcore natural language processing that is really expensive and takes a long time, we're like, all right, let's just narrow down to a subset that we believe to be relevant, and then we'll do the more fancy stuff. So we kind of build this funnel where now you've reduced your space to 2,500 possible papers that are somewhat relevant to hopefully the person's question. And then this is where we do a little bit more of the advanced natural language processing, where we do what's called, we create embeddings with the question, which basically means we create numerical representations of the question and then look to match the text of sentences that we believe to be claims made by the authors. So there's kind of two parts of that. So basically we have an algorithm that looks through the sentences of the abstract and says, when are authors making a claim based on the evidence? And we've trained this model on a bunch of annotations from scientists where they mark up papers themselves and say, here's a claim, this isn't a claim, this is background, this is methods, this is a claim. And we're able to teach a model how to pull out those sentences. And basically we embed your sentence. So we have this numerical representation, and we have all these sentences that we've now pulled out of papers that we think are claims, and we try to match them together and say, we kind of know the meaning of what this person's is saying by this numerical representation. We have it for the sentence of the paper. Let's try to find the best matches. And we do that, and we basically pick out the top 50 best matches. So now you have 50 possible sentences that we're going to now show you. Does that make sense?
Yeah, it does. So basically you start out with...
There's one more part. There's one more part.
Okay, one more part.
And then the coolest part happens, where we built this one last module that we call our Q&A module, where we basically try to go a step deeper on the questions the person's asking and really parse out like what information are they actually looking for, what is the intent of the question, and then we reorder those top 50 solely based on how well we believe it to be answering your question. So we've built this funnel down to give us the top 50, and then we run another model over it. We're like, all right, what are they really asking? Can we show them information that answers their question? And then we re-rank them, and that's how the final order is presented to you.
Awesome. So how quickly is that done? Because it seems like the first part's pretty quick, like because you're basically doing a Google search on this set of documents with the keywords. Then you're getting it, then you're taking it a step further, and then taking it another step further.
Yeah. And because of that funnel, in each subsequent thing is a little bit more compute, but it also then just becomes smaller and smaller. It actually only takes us about 5 seconds.
Wow.
The keyword takes like 0.1 seconds. Then the next part, I'd be lying if I said the exact amount, but we're only doing that embedding part on a few thousand, and then there's only 50, and then we're doing the Q&A part. So it's actually really, really quick, and that's why we've constructed it as that funnel.
And like you said, all the data is coming from scientifically researched papers, and they're all coming from things that are cited. I'm guessing that your results will show kind of like how many citations something has, or the authors and things like that. So it's more academic oriented.
Yeah, totally. Yeah, and so you can think of the list of results is basically a list of featured snippets from research papers. So if you say, what are the benefits of vitamin D into consensus? What we're going to show you are snippets from papers that are authors making their claims that hopefully answer your question. So they'll say something like, the first one could be, our results suggest that vitamin D improves your immune system. The second one could be, our results suggest that vitamin D helps with weight loss. I know it doesn't, but I'm making things up. And there will be a list of basically featured snippets, and then you'll have the accompanying metadata below those snippets that are, what journal was it, who are the authors, how many citations, and whatnot.
Cool. And so when it comes to the use cases for this, I see so many of them, when even not just, my brain's going to go to the student side, being a teacher and, having taught students for a while, but there's also a lot of benefits when it comes to companies and businesses. We just came through this whole pandemic where a lot of people didn't know what to do. We didn't even know, really anything. We're hearing different stories, different things from different political sides. And if we could just get the data, we might be able to make better decisions as a company, as far as like back to work, bringing people back in. How do we safely do certain things? And I'm seeing this as a tool that could help me with that.
Yeah. That use case that you just mentioned is great, but it does have the quality that like it's kind of like one-off in some ways, right?
Yeah,
like
yeah. We're not gonna have another pandemic tomorrow, right?
Hopefully.
Fingers crossed.
And like where we want to work with businesses is more where it's more part of your weekly weekly job, where you're needing access to good peer-reviewed information. And where we kind of want to start, because we've built this tool for ourselves, for the consumer, to be able to be picked up by anybody. And we're not, we are being used by a bunch of researchers, but we're not explicitly setting out to make this be a tool that helps researchers conduct more research. It definitely can be used like that. But like I said at the top, like our goal is to help more people access this information. So really what we're looking for in people and businesses are people who are not necessarily hardened experts or researchers themselves, but need this type of information. So I'll give you a perfect example of business would be somebody who's a healthcare consultant, who is working in healthcare and is working in this kind of scientific domain, but they're likely not a PhD themselves, right? They're maybe an MBA, or maybe they're only 2 years out of college and have an undergrad degree in business or something, but they're interfacing with clients in healthcare, maybe hospital chains or physicians' offices or biotech companies, and they're continually making recommendations and having to do analysis about these scientific topics. And many times when they're coming up with their hypotheses or they're making recommendations, they need to have peer-reviewed information that supplements it. And we can now be a tool that makes it a lot easier for that type of person to get that information and share that information with clients.
Awesome. Yeah, no, I think that's great. I think that's a fantastic use case that you mentioned there. What are some of the other things that you guys are working with? I know, pre-call, we talked a little bit about Dolly and image generation and things like that. And, stable diffusion is another example of tools like that. And what's your kind of relationship with those?
Yeah. So what you're referring to is if anybody spent any time on tech Twitter, I'll call it, you've definitely seen DALL-E or these stable diffusion models. And basically what they can do is what DALL-E can do is you can type in a prompt and it will generate the AI will generate you an image about what you said. And how that relates to us is the core underlying technology is the same. So they use, we use and they use at the highest level. It's this subset of natural language processing called large language models. And it's this new technology only as of the last few years ago, where we have these models that are trained on billions and billions of words. And the way that they're trained is that they are basically given just the articles of text on the internet. And they use that to basically develop their underlying understanding of human language. And the way that they train them on that text is that they blind words in articles, and they make the model make a prediction on what is the missing word. And then, it tells it if it's right or wrong. And then it can just basically tune itself to make it be way, way, way better at making predictions on what word belongs in this blank space. So then it develops this understanding of the way language works. So it's this huge giant model that's shown billions and billions and billions of words. It learns about human language. So it comes with this like base layer of understanding. And then you can take that and you can have it do a bunch of different things. So in Dale's case, they paired it up with a computer vision model that can generate images, and they taught it how to generate images given a prompt. But you can also do it for a bunch of other tasks. So in our case, we take these language models and we teach it how to look through a paper and pull out what we call a claim, where a scientist is stating their claim based on the evidence. These are two super different tasks, but it actually still comes from that base layer of understanding of human language. You then just give it your own custom built, fine-tuned data set to teach it how to do a specific task with that language. So basically the huge innovation is that these models come to you with this really deep understanding of human language, and then you can take it and train it the way you want to do a specific task. And while our tasks are very different than what DALL-E does, it's actually the same underlying technology.
Yeah, I think that's super cool. And just playing around with Diffusion B, which is the Mac version of Stable Diffusion that you can easily install. If anybody wants to go, check that out, they can. I put in all kinds of weird, things, just writing stuff up, and it's remarkable the images that are created by this tool. Like just now, I put in Northwestern Football, Eric Olson, and it creates a person in a purple uniform, football, helmet, running on a field. It's like, well, it's pretty close. I mean, it doesn't have the right logo or anything like that, but
pretty darn cool. Yeah, it's interesting. Like we used to think that the last place that AI was going to come was in these like subjective domains where art, humans are doing something creative in art, and that's turned out to be pretty darn wrong. And it's coming for that as one of its first use cases. And I was talking to my co-founder about this, and we think there's two reasons why that's the case. The first is kind of what you just said there, where art in these domains, it's really subjective, and you can't really be wrong. So you type in Eric Olson, Northwestern football player, like if it just does something kind of similar to that, it puts a smile on your face. It doesn't there's no real consequences, and
right.
it just has to do something kind of similar. And it's like, oh, this is really cool. So I think the stakes are really low, and I think that's a reason why it's able to do this early. But the other one is more technologically feasible why it's able to be done. And that's because it comes, there's a freely available giant training set of data to do this, and that is the Internet of Images. And the reason why that's so perfect is because every image across the internet comes with a little caption to it. If you just scrape that, you now have a billion parameter data set of image caption. That's the holy grail with these things, right? You have this giant, perfect data set already created for you with very minimal work. You have your text that describes the image, and you have your image. You can now train a model to say, given text, this is what I'm looking for. Do this for me. So it's kind of this ready-made data set in a domain that has low stakes to it, is kind of this perfect storm to create a place for AI to live early.
Yeah, that makes perfect sense. And we as, web developers have kind of amplified that with our, all of our meta tags and title tags and description tags that we put
in
everything.
All free. You just scrape it, and now all of a sudden you have, you don't have to pay for custom annotations or go do all this fancy stuff. It's like you have the data set ready to rock.
Yeah, it's just a matter of continue the scraping.
Yeah, exactly.
Yeah, awesome. So Another thing that I wanted to talk a little bit about, with your background in predictive analytics, is there an opportunity to use this kind of technology to look at other data sets that are there, maybe not from scientific papers, but going back to your background at DraftKings at sports data and putting this stuff together and finding out like who should we draft next year and and what teams, as a business, even like, which of these high school players coming out should I look at signing NIL deals with or something like that, that may have the biggest impact next year.
Yeah. Yeah. I mean, this is something that I am super interested in. I'd say that in terms of like, yeah, the evaluation of people, it is definitely used, or like, there's definitely predictive analytics being done to do that, to make decisions about drafting players. Don't know about the high school level because there's a lot less uniformity in like the statistics that are output in high
Yeah.
school. Or like
Competition's way over the scale, all over the places too.
how do you adjust for the kid playing in Plano, Texas versus the kid playing in, a suburb in New Hampshire? Like,
Right.
and you look at the statistics they've output, you'd have to build a really fancy model that is able to say, well, this is done with way worse competition, so we need to value these people differently. Yeah, it's like that. I don't know about, but as far as like drafting players, yeah, there's already a ton of stuff done that you try to take, the outputs of what players did in college and what level of competition and try to make predictions about how they project. But even that still is, there's a lot of sticking your finger in the wind. And there's a reason why NFL teams or any pro team, do these long interviews with players where they're asking them all sorts of crazy questions because they want to understand who they are. Because sometimes it doesn't really matter what you did in the field in college. It's much more about like, your underlying wiring as a person, which is pretty darn hard to quantify. But the part of sports that I think is most interesting in the application of this is, for me, is in-game decision making. And I'm obviously biased toward football as my favorite sport and what I'm most interested in. But if you've watched a football game over the last 2 years, you've definitely heard the quote unquote analytics debate and going forward on fourth down and punting or kicking field
2-point
goals,
conversions. Yeah.
all of the above. And that is where we're seeing it pop up the most, and we're starting to see teams be a lot more aggressive because unlike what we just talked about with these player evaluations, these decisions in game is mostly a solved problem. We basically have all of the variables we need to build a model to tell us what is the right decision by the math. Now, there's going to be your old school guys that say you still need this subjective analysis. You need to know the feel of the game. I don't know if I agree with that personally, but I think it's a really interesting domain because, really interesting like part of this whole world, because we have all of the variables we need to build these models. Yet there still is this camp of people who says, no. You need to how feel the feel of the game to really make the decision. So yeah, I think it's a really interesting application of this stuff.
Well, I think we're starting to see that. Like right now, you look at the NFL, there's more young coaches that are using data and analytics that are winning Super Bowls and games right now. I mean, look at the Eagles. I mean, 5-0. I mean, using a lot of data to make decisions on the field, whereas some of the older coaches
6-0 now as of last night.
Yeah, 6-0. That's right.
Yeah.
That's right. Just beat the Cowboys.
Yeah.
Which, and going back there, now you look at, what about contracts? What about like, are they going to be affected by things like this? Because you're looking at Cooper Rush for Dallas as having a heck of a season coming off the bench, as a backup quarterback, and his salary is significantly less than Dak Prescott. So we're going to have some way of using analytics to really make decisions on salaries, not just the field.
Yeah, and that's another really interesting way that it's being applied. And one of the most interesting insights that is now pretty universally accepted, that is in large part comes from analysis of the data, is running backs and running back contracts, and how the data says you should never, ever, ever pay a running back a big contract. Because basically, this was, Belichick was ahead of this game. He was doing this in the early 2000s where he never, ever signed a big running back. He just used a stable of a bunch of different guys with no names, just like was like kind of more intuitively knew that these guys were pretty interchangeable. But the data basically tells us that the big insight came, there's this thing called the big data bowl. where the NFL analytics department puts on this competition for any data scientist can build models. They basically come up with a research question. They say, hey, make a prediction on this, and we're going to grade all of the results and select winners. And the research project like 3 or 4 years ago was we're going to give you this like player tracking data of the start of every play. And you have to make a prediction of how many yards are going on run plays, how many yards are going to be gained. And all these amazing data scientists built these really cool models. And the conclusion of every single one that did good was that the name and who the player was did not make the model any more predictive. So basically, the running back's outcome had nothing to do with who the running back is. It had everything to do with what was happening around them. And basically, the idea is that there's no position in sports that is more affected by the people around them and less about what they're doing than running back. If your offensive lineman whiffs on a block, it doesn't matter if you're Adrian Peterson or the third string running back in high school. You're not going to go anywhere if a 300-pound defensive lineman is standing right in front of you. And it's intuitively really hard for people to grasp that sometimes because they see Derrick Henry running down the field and you see this giant freak of nature running a 4.4. But if you go back and look at the stats in games when, their offensive line isn't blocking well, Derrick Henry doesn't do well. And there's no real corollary to that in many other sports where you're so dependent on the things around you. And basically, it was really with data that we were able to figure out, we might have known some of this intuitively, but it really is true. And that you should really never give them big contracts because of that.
I think when you look at it, I mean, I'm starting to see it now more than ever before, is that offensive line is probably should be the highest paid.
I mean, I'm a former offensive lineman. You don't need to convince me that. I mean, quarterback is important, but after that, receiver, O-line.
Well, quarterback can't do a whole lot if they're getting, tackled every down, if they're getting sacked all the time. So
totally. It all starts up front.
Yeah. And another thing that I've seen a lot of, is, when it comes to like sports betting and using data there, and not just with football's, an easy one, baseball also, but there's so many things that people can get data on and bet on. Like I'm a UFC fan. So when watching the UFC, you have like different, like when is someone going to get tapped out or how long is this match going to last? And all that is so fascinating to me of how, there are ways to predict this stuff and get pretty darn close. There's always outliers, and there's always going to be outliers, but it's interesting.
Yeah, and totally. And there's people model every type of sport nowadays, and there's really great resources to scrape data and build your own models to make predictions on things. And the hard part is that the books are doing the exact same thing, so they're trying to make these models, and what you're trying to do is build a model that says, do you believe it to be different than what the book is predicting? And if you build the best model in the world, a very high percentage of the time it's going to just agree with the book because they've built pretty darn good models
because they were there first.
But the smaller your market and the less eyeballs on it, the more likely that the model is going to be good. So UFC would actually be a pretty good example of some of those derivative bets in UFC maybe aren't actually priced that well. And there is an opportunity to build a model that predicts it better than the book because they're not.
I think especially on the undercard, because you're getting fighters that had like 3 or 4 fights that aren't in the UFC. And if you can get their data, pre-UFC and some of their amateur fights or some of their fights in other organizations, put that in, you're going to have a better model.
And it's the book being like all knowing and smart it's kind of an overdone phrase. And like, don't get me wrong, there are places that are very sophisticated, and for sports like the NFL, you're not gonna. There's like 100 people in the world who will consistently win year over year in the NFL, and people don't really understand that just because it's just such a solved problem of building these models to make predictions for the books. But people underestimate the book in something like that in a really mature market like that, but they actually really overestimate it on the other side of things in these smaller markets. And I think people would be really surprised at how many opportunities there are to do well in some of these smaller, more derivative markets that they just don't have the resources and time to dedicate towards building perfect models and the perfect systems to handicap.
And probably not as profitable from a bottom line.
Yeah, it's just not worth it, right? And and we also just don't think there's going to be that many people out there. They're going to build a model to beat their UFC undercard time to finish market.
Exactly.
Is it really worth dedicating 2 data scientists to go build you that perfect model? No, it's not. Like, you're just going to keep it pretty low limits. And if you lose a couple bucks, you lose a couple bucks. So that's really where the opportunity is as a bettor is some of those smaller markets.
Yeah. This has been a great conversation, very fascinating and super interesting. How can people learn more about the things that you guys are working over at Consensus, and how can they connect with you online and maybe even sign up?
Yeah. So like I said earlier, the app is completely free to use right now. So go to consensus.app on your web browser, and you can create a free account and start asking questions about what the science actually says about the things you're interested in. And then, definitely give us a follow on Twitter at ConsensusNLP. We try to tweet out interesting things, queries, results we found. And we want to try to get ourselves out to as many people as possible in these early days, get a bunch of feedback, learn how people are best using the product. So we'd love all the help we can get, and sign up and create your free account.
You bet. And I signed up for my account just a couple of minutes ago, so I'm definitely in there. And I'll make sure I'll link this up in the show notes too at geekleader.com, so people can go there and sign up. And really appreciate it, Eric. It's been a great conversation.
Yeah, thank you so much, Sean. Thanks for having me on.
If you enjoyed that episode, please leave a rating and review in Apple Podcasts. I'd greatly appreciate that. And also, don't forget to check out merch. We have some T-shirts that I've designed that are on at geekleader.com. You can click on the merchandise section there and check that out. And also, don't forget about the books from our guests. So if you like this guest and other guests that have written books, please go ahead and check that out at geekleader.com. I would greatly appreciate it, and I'm sure they would too.